So this is Math 10-3. We are doing lesson 4.2, mass in the imperial system. So remember that there's the metric system or the SI system and the imperial system. And so we want to talk first of all between mass and weight, because generally in the imperial system we don't actually deal with weight, with mass, we deal with weight. And we equate them, and they're slightly different. So let's just take a look at what our definition of mass is. Ooh, typo there. Let's fix that. So the mass is the measure of the amount of matter that an object contains. So if we think of matter made up of molecules, objects made up of molecules and atoms, if you think of it as the number of Lego blocks, how many of the Lego blocks are molecules that are there, that there's a certain fixed amount in an object, and that's the amount of matter and mass that an object has. When we compare that to the weight, weight is a measure of the force of gravity acting on the object. Now, it's important to know that the more massive an object, the greater the force of gravity. The smaller or the less massive the object, the smaller the force of gravity. And so they're certainly related, but they're slightly different concepts. And if we think about mass versus weight, I'm going to just show you a video clip that I put together this morning to help emphasize that. So just give me a second, I'll pull that up here and we'll play that video clip. So the recording I'm going to show you is of the moonwalk in 1969, and the purpose of showing you this video is to give you a sense of the difference between mass and weight. So these men have the same mass, roughly, as they had on Earth. They might be slightly more massive or slightly less, you know, things dropped a little bit of weight or put on a little bit of weight over I can't remember how long it took them to get to the moon, but over that trip, right? But generally they're the same mass. But if you watch, when I turn the video on, when you watch them walking, you'll see that it's like they have this spring in their step, and it's because the gravity on the moon is a sixth of that of Earth. And so their muscles are strong, built by the gravity of Earth, and now they have the ability to just bounce. And so I want to just show you that. So you can see him bouncing there and just walking along, and it's just without hardly any effort, he's able to do those little jumps. And shortly there'll be another astronaut come into the screen, and you'll see him actually bounce and jump and hang in the air for quite a bit of time. And so we'll just let this play for a little bit longer, and we'll see that second astronaut come in. And I don't remember their names. I'm not very good at that sort of detail, but this is really, and you'll just see him here a little bit, just hang, just, you see, so it's quite phenomenal, the amount of energy or appearance of spring they have. Okay, and so that is all I wanted you to see in this short clip. Okay, so that helps distinguish between mass and weight. As I say, we tend to talk about weight in the imperial system. So let's look at the units of weight in our imperial system. So our first glimpse is our 3 units. We have ounces, abbreviated OZ, pounds, which is abbreviated LB, and ton, which is abbreviated TN. And their relationship to each other is that we have 16 ounces in 1 pound and 2,000 pounds in 1 ton. And that information sits on your formula sheet right here. Just give me a second, right in here. So this is the front page of your formula sheet, and so those relationships are sitting right there for you. At this point, don't worry about the metric system over here or conversions between the metric and imperial system. We're just focused at this point on our imperial system, and that sits right there if you don't have that memorized. Let's go on to look at some examples. In example number 1, we have Manuela needing 1 pound 8 ounces of brie cheese and 12 ounces of cheddar cheese and 15 ounces of Swiss cheese for a fondue recipe. How many pounds of cheese does she need? So we need to add those together. We have our brie, and in the brie we have 1 pound 8 ounces. With our cheddar, we have 12 ounces. And then our Swiss cheese gives us 15 ounces. And so exactly like when we worked with feet and inches, we keep those two separate. So if I add these together, I have 1 pound and 35 ounces. Let me just double check that, 8 and 10, yeah, 35 ounces. And this 35 ounces needs to be converted into pounds. And we know that we have, for every ounce, we have or for every 16 ounces, so I have 16 ounces, and that's equal to 1 pound. And I want to know how many ounces how many pounds 35 ounces is. Now there's a couple of ways we can do this. We can take and multiply, just made a small error there. That should be our x, that's what we're looking for. So we can cross multiply and divide and work it out that way. That's one way to do it. And that'll put our pounds into a decimal system as opposed to in pounds and ounces. So my preference is not to do this, but to look at how many ounces I actually have, or how many pounds I have in this 35 ounces. So my first 16 ounces, that gives us 1 pound. And then another 16 ounces gives us a second pound. So that's 2 pounds there. Add that together, that's 32 ounces equaling 2 pounds. So I can subtract out 32 ounces here and add 2 pounds here. That leaves me with 3 ounces altogether. So when I add this, I have 3 pounds and 3 ounces. There are, as I say, alternate ways to do that, and you can look at that question in for alternate ways in the workbook. And the numbers are slightly different, but it's the same concept. So we answer that with, and I'm not quite organized in my brain today. Manuela has 3 pounds, 3 ounces of cheese. Let's now look at example number 2. The cab of Arthur's semi-trailer truck weighs 8.7 tons, and the trailer weighs 6.4 tons. If the loaded gross weight of the truck is 21.3 tons, what is the weight of the load in tons and in pounds? So what do we mean by the loaded gross weight? Well, that is the loaded gross weight. That's equal to the weight of the cab plus the weight of the trailer plus the weight of the load. Okay, gross means all of it. And we're being asked to determine the weight of the load. So we can just substitute in here. We have 21.3 tons, and that's equal to 8.7 tons. That's the weight of the cab. And then the weight of the trailer is 16.4 tons plus the load. And I'll just call that L. We don't know what it is. So I can add these two together. And when I do that, I get, let's see, I believe that's 15.1 tons. So I have 15.1 tons plus the load, and that gives me 21.3 tons, which is our gross weight. So I am going to subtract the weight of the cab and the trailer from the gross weight, and what's left there is the weight of the load. So if I just subtract out 15.1 tons, and I subtract that on both sides, so I'm canceling it out, I'm left with just my load here, and that's 6.2 tons. 21.3 minus 15.1 gives me 6.2 tons. And so now I've answered that in tons. The next thing I need to do is answer it in pounds. So I know that 1 ton is equal to 2,000 pounds. And if I have 6.2 tons, how many pounds am I going to have? Well, if I take and multiply 2,000 pounds by 16 tons divided by 1 ton, that gives me X in pounds. So 2,000 times 6.2 gives me 1,200 and, sorry, let me say that again, 12,400 pounds in my load. So the load is 6.2 tons or 12,400 pounds. Example number 3. In example number 3, we have a 12-ounce can of vegetables, and that 12-ounce can costs $1.49. And I have a 1 pound, 2-ounce can of the same vegetables, and it costs $2.19. And which is a better buy? When we compare, we're having to compare two amounts, the cost of two amounts that are exactly the same. And so the easiest amount to use is ounces. So if I think, if I go with my first can, it costs $1.49. And if we put that over the weight in ounces, I put that over 12. So $1.49 divided by 12, I just take and calculate that out, and that comes out to 0.1242. So that's 12 cents. So it's not quite enough to, wouldn't round it up to 13 cents per ounce, but it gives us, a little more than 12 cents an ounce. So now we're going to do the second can. Only this time we have 1 pound and 2 ounces. So that 1 pound is equal to 16 ounces. So I have 16 ounces, and then I need to take that 16 ounces and add the 2 ounces to it. So I have a total of 18 ounces. And that allows me to compare these, because now when I divide the total cost by the total number of ounces, it will give me the cost per ounce, which is exactly what we're looking for. So I have a cost of $2.19, and I divide that by 18 ounces. And we put that into our calculators, and we come out with 0.1217. So really close in price. Again, if we think of this as pennies, that would be 12 pennies or 12 cents. And if we go into that hundredth of a dollar or a tenth of a penny, we can see that the first can is slightly more expensive. And so we know that the 1 pound 2 ounce can of vegetables is the better buy. And now let's go on to our last example, example number 4. Valerie bought 4 pounds 6 ounces of steak for dinner at $2.74 a pound. After removing the excess fat, she has only 4 pounds of meat. What is the true cost of the meat per pound? And so we know what it costs with all of the excess fat, but the true cost takes and looks at what is the usable meat that's there and compares it to the total price. And so we need to go, how much did she pay for that steak? Well, we know that she pays per pound. And so we have 4 pounds 6 ounces. We have to convert that 6 ounces into pounds. So I know that if I have 6 ounces and I divide it by 16 ounces per pound, that gives me the portion of a pound that 6 ounces is. So I divide that out, 6 over 16, and that gives me 0.375 pounds. So the 6 ounces is 0.375 pounds. So now I look and I go, okay, I have 4 pounds plus the 6 ounces. So the total amount of meat I purchase, or Valerie purchases, is 4 pounds, 4.375 pounds. We multiply that by the price per pound, $2.74 per pound, and that gives us the cost. So we're purchasing or calculating our cost of our meat. So we put that into the calculator, multiply it out, and we get $11.99. So she pays $11.99 for 4 pounds of usable meat. There's that 6 ounces of excess fat. So if we want to determine the price per pound, we have to take the cost that we paid over the amount that she's purchased. So she paid $11.99, and she purchased 4 usable pounds. When we take and divide that out, it's just slightly less than 3. So 2.998 or something like that. So it ends up rounding to $3 per pound. And so notice that it's $3 a pound, which is really more than what they're charging for you. So you have to, again, be cautious when you make a purchase, how much of of the mass that I'm purchasing, or the weight that I'm purchasing, is waste. Okay. So Valerie pays $3 per pound. Now I want you to do some practice out of your workbook. So there's building your skills, and there's questions. There's 4 examples, and there's practice, 3 practice questions for each example. And then there's practicing your new skill, and I'd like you to practice your new skills as well. So there's your page numbers. Have yourselves a good day.